something like that would be just fine. Okay, now this is the tedious part of class. We have to run the clock all the way to 2:30. We'll always start class exactly at 2:30. So that way, if you walked into class right at that moment or logged into Zoom right at this moment, you'll know you haven't missed anything so far. It's official, folks. Looks like we can get started. Welcome back, everyone. So today it's going to be kind of a lighter day. Our major goal is to introduce the class, show how the operations are going to work, the homework systems, the textbook. And if we have a little bit of time and energy at the end of all that, we'll get into a little bit of mathematics in section 2.2 of the class text. I think the best way to start off the semester is just to turn it over to you folks. Any questions at all whatsoever before we get started today? Okay, that's kind of an uncomfortable silence, but this is a pretty strange class. We are rolling together two sections all into one. And one section, section 2, is the in-person section. The other section, section 22, is the online section. And so usually when I call for questions, I'm going to try to pause between 5 and 10 seconds. That's kind of an uncomfortable silence, but that gives everyone an opportunity to respond. For the online section, responding by voice is usually the preferred way. But if you prefer to use chat for whichever reasons that might work better, don't hesitate to just respond to the chat. So I'll always give a lot of time after I call for questions, just so people can collect their thoughts. You might be typing out a message, those kinds of things. There are a long silence to wait for about 10 seconds, but we'll get good at that. So again, weird thing about this class is two sections all rolled into one. My intent is to make this essentially the same exact class, no matter what section you're in. But one thing I also want to highlight is, if you ever see a class where there's a section 2 and then suddenly a section 22, that's a linked class. That means the online section 22 is also being ran concurrently with the in-person section. So it's a tougher, fully online class in that sense. But we'll get through it. We'll make it happen one way or another. Let's see. Other things we want to talk about is, I guess the total class size is currently 20. So we're doing, let's see, pretty good on that end, I'd say. In Zoom, we've got 11 altogether. Let me see here. That looks like 11 in Zoom, 2 in person in class. So maybe not the best, that is also counting me. But if you do miss a class meeting for whatever reason, maybe it's a technology problem if you're in the online section or something along those lines, you can always go down here to the recorded lectures, and this is where all the recorded class meetings are going to show up. Aside from that, today we're going to go through again the Moodle website, the syllabus, those kinds of things in the book. I don't want to take too much time in the syllabus. In the past, I used to read this out practically line by line. Let's skim through it with the understanding that you'll have more time to take a closer look at this. Probably a lot of you already have. So let's open it up. And the thing I want to spend the most time on in this syllabus is pretty much right around here. I think this is the most important part about the syllabus because this helps us find out how to get in contact with the instructor, how to get help outside the classroom, all those kinds of things. So again, we have two sections running at the same exact time, but meeting in different ways, different locations. And if you need to ever get in contact with me, there's lots of ways you can do that. You can send me a phone call, a message, a text message to that phone number. That's a little bit tricky because my phone is almost always silenced. I sometimes forget to unsilence it. Another way to contact me is just by email. I'm highly responsive on email. I mean, this is what it looks like on my computer. I usually have multiple browsers going on. Chrome is my dedicated one for email. I'm pretty much working always like this on my personal desktop. And the moment a new email comes in, I get a notification here. Somehow my brain just always responds to that. I try to be highly, highly responsive by email. This is great for a class that has an online section since getting in contact with me through office hours isn't always so easy. So think of email as an alternative way to do office hours. no matter what you're working on, what your question is, you can always send me a question to this email directly. If you're working on a quiz and you get stuck, if you're working on a homework problem and you get stuck, you can take a screenshot of what you've done so far, maybe on your computer or just an ordinary cell phone picture of what you have on your paper, send it to that email and I'll respond to you, potentially using digital tools to give you an in-depth response. I'm highly responsive on email, like I mentioned, a pretty fast typist, great with the digital pen. So there's no way you can really overload me on emails. Even if you have a lot of questions, don't hesitate to send them out there. So that's my big way I usually work with a lot of students, is directly through email in this way. Because once again, my office hours, I try to make them as sensible as possible, but I found after doing this kind of work for quite a while, it's almost impossible to put down office hours that works for even a majority of the class. Our schedules are just too crazy and different. But if you need to get in contact me with office hours, I have an open door policy with office hours. You can just drop in. I'm available 4 to 5:15, Monday and Wednesday through Zoom. It's the same Zoom link you see on the Moodle website. So everyone in the Zoom class have already found that. For those in person today, the Zoom link is found right down over here. So this is a Zoom link that anyone in this class could use for office hours. And by the way, if you're in the in-person section and we're in the winter season, if the roads are just too crazy for you, no harm done if you decide to use the Zoom link yourself as well. So if there's just a bad snow going on in your area, this is open to anybody to use. Again, it's also one way to do office hours. I also hold office hours in person in the Student Success Center. This is room 220. I was there today from 1 to, I have to admit to you, 1:50 p.m. since no one showed up. But on a real typical day, I go from 1 to 2 p.m. right on the minute. So if you're on the campus, even if you're on the fully online section, feel free to drop in on a class or the in-person office hours here where it's highlighted, and I'll be very happy to work with you. Another time I have is on Thursday. These are kind of weird times. And this one is also in person in the Student Success Center. So 2 hours through Zoom. This is mainly to target office hours for the fully online section. 2 hours in person. This is mainly for the in-person folks, but anyone can join any set of office hours whatsoever. And again, if none of these work for you, sorry about that. Again, it's tough to get schedules to line up. It's very chaotic. You can always just directly email me. We can work something else out. And don't hesitate to just email your question through the email. I'm very happy to help out that way as well. And by the way, as far as it comes to the emails, like I mentioned, you can send me as much emails as you have, as questions as there are. You're never going to overload me or make me somehow feel badgered or anything like that. That's impossible. It's literally my job to respond to these questions. And you can send them at any time whatsoever. I'm typically checking and responding to emails in the early hours of the day. I teach exclusively night classes, so right now I don't really have a chance to even read them and look at them. But if you have an email question, say at 5 o'clock today, that's totally fine. Just send out that email question. As the moment it's on the tip of your mind, that's the best time to send it out. If you're working at 1 a.m. and you have a question, I'm sorry you're up that late, but go ahead and send the email. I'll get to them when I wake and working on those emails in the early hours. So you're welcome to send your emails at any time, weekends, stuff like that. And I check them every early hour morning. So that's pretty much how to get in contact with me. Any questions or comments so far, folks? Okay, again, those are really uncomfortable silences. I'm always trying to give the Zoom class a chance to respond where there's latency you have to deal with, but it is a little bit trickier. And by the way, everyone who's in the in-person section, they're looking at a projector. The class actually looks different if you're looking up here versus looking at the materials through Zoom. So to give you a feel at what I'm looking at through this desktop, this is what my screen truly looks like. So I have these weird controls I can do nothing about. I have this annotation bar that doesn't go away. This little slider thing, it's supposed to auto hide. It doesn't. There's something weird about the installation on this computer. It doesn't hide, so I lost some real estate up here. And I have this participant window that goes directly down like this. My hope of hopes, and I actually asked the administration or the administration about this, is they would give us a powerful enough machine with a great enough resolution that my screen would look like this. Maybe a dual monitor setup, something like that could work. I think if my screen looked more like this, that would be fantastic. It'd be a more immersive course, but we're pretty limited on the hardware. We have a resolution limitation up there. They've only supplied me with one monitor, so I'm kind of limited on what I can do here. So once again, the class pretty much looks like this for the folks coming in through Zoom. And so I try to pay attention to everyone in the Zoom class by looking at this sidebar here to the right. There's lots of little things that you can do here. You can use controls where you might raise your hand for a question or a thumbs up to say you're got it, you're good on that concept. All sorts of stuff you can do to participate. So anything that you can do to indicate some form of participation in the class is great. And I'll always try to keep one eyeball here to the right to pay attention to that. Trickiest thing about the Zoom class for me, though, is this. I like to allow participation through chat because a lot of times that just makes sense. You could be in a noisy environment, for example, lots of different reasons. But if you do send a chat through in a Zoom class, I have to pay attention to this spot right here. It'll turn into like a 1 to say I have a new chat. For some reason, that's actually really, really easy for me to miss. So if I miss your chat, really sorry about that. I'll definitely open it up at some point and get to your question. But for anyone in the class, if you just notice I have a chat and I'm somehow ignoring it, whether you're in person or in Zoom, don't hesitate to just call out, hey, Mike, you missed a chat. I'll get to it right away. That kind of stuff is never considered rude. Sometimes I just need a little bit of extra help to pay attention to all the things that can be happening in this little space here. Well, any questions at the moment about that, the setup we're working on? Okay, let me close this out. Okay, I guess we're going through the syllabus. We should continue to do that so we don't have too many threads open. But again, we're going to kind of skim through this. For the calculator policy, the main thing that's going on here is we're trying to exclude the graphing calculators, like say the TI-83, which looks something about like this thing right here. So graphing calculators that look like this are not allowed on real exams, but any kind of other basic scientific calculator would work just great. So typical ones would be stuff like the so-called TI-30XA. Some people really like this calculator. It looks like this one right here, about $10 you could purchase this one for. I'm not a fan because I think this one is actually tricky. You have to have a good head of order of operations to work with this one, but you may have been working on it on other classes. If you're great with that calculator or that kind of calculator, I'd say go for it. This is the one I would recommend, something more like this calculator, because the idea with this calculator is you can put a whole line of an expression and do a huge computation without going bit by bit. So pick a scientific calculator that makes the most sense, and you'll be in great shape. If you're not sure if the calculator you have that you intend to bring to an exam fits the calculator policy, just send me an email. Give me your calculator model number, and I'll double check it for you right away. I should be able to determine that very quickly. Any questions at all, folks, about the calculator? Okay, well, continuing down the syllabus, let's get down to this part right here. We'll say a lot more about this. This is part of our objective today to introduce this online homework platform. To actually register with this, you need this right here. This is the so-called course ID, and you need one other thing. This is where it gets a little bit vague for me because the ISU book bundle policy is something they're still trying to figure out. It works differently in class by class basis depending on the publisher. This is a Cengage platform that we're using with WebAssign. Let me tell you what I think the book bundle is doing. And correct me if I'm wrong, because again, this is all pretty vague. If you are in the ISU book bundle program, it means you haven't opted out. They auto-rolled everyone as opted in. That's an ethics concern already on its own. But if that's the case and you're in this class, they should supply you with a registration code that you can click on here and get registered for WebAssign. Is that what folks have found is the case? It's like that seems to be about right for people in class. How about for people in Zoom? Is that how it's working out for you so far? Awesome. Glad to hear that. Thanks for the response on that, Riley. So registering for WebAssign shouldn't be too big of a bear. If you have the code because you opted in, click on this link right here, and it gives you a step-by-step guide on getting registered. First thing it wants is the course key. Go back to the Moodle website. I called this class key, course key. Let's see if we can fix this real quick right here, just for a little bit of parallelism. The book bundle program is complicated enough. Let's call this, once everything loads, the internet's kind of slow today, course key. Okay, so it's the same one down below here, duplicate here. You just need to call it course key twice or else that's confusing. Drop it in by copying and pasting, and it gets you started with accessing the course. What you should see is the biocalculus textbook, the instructor, Michael Jacobson, and the sections 02 and 22. If that's the case, you're in the right spot. Then registration is pretty fast on this thing. It looks like 10 students in the class have already registered, so good on you all for being on the ball with that. If you haven't registered just yet, no worries. You are still caught up complete with the course. We're only just getting started today. So WebAssign is going to be the online platform where we do a lot of the practice with calculus problems. We'll discuss quite a bit how it works when we come back on our next class meeting on Thursday, when more people are registered and you'll have a chance to work on it in the same time I'm demonstrating it. I'll show a little bit about how it works today, just so we can get started. So aside from the online homework, we're also going to assign weekly quizzes. And the weekly quizzes are never meant to be a big deal in this class. Here's the kind of idea. An online homework platform like WebAssign is great because you get immediate feedback on if your answer is incorrect or not, is incorrect or correct, and people do like that. But there's a huge limitation on WebAssign. It has no way to give you any feedback on your step-by-step solutions. So it's hard to tell if you're thinking about a problem is right, if your solution was just a fluke, or if it was a true solution and the method to find it was accurate. So because of that limitation of WebAssign, the quizzes down below are really meant just to be additional homework. It's your chance to write out the whole solution as if you're solving a real exam problem. And at that point, it can give you feedback on your total process. Because it's meant to be an additional homework assignment, I'm not going to put a lot into the quizzes. Usually they're pretty short and sweet. They kind of just capture the last week of work. And what else do we say about these? You're welcome to work in groups on these quizzes. Again, think of them as just an additional homework assignment where I can give you extra feedback so you're prepared on exams. And you're even welcome to ask me questions on the quizzes. Again, there's no secret on how to solve these. I'm really happy to assist with that. So quizzes, think of this as just additional practice throughout the semester. And as far as the homework, the quizzes, and the examinations go, that is what fills out this table down below. Homework and quizzes is really huge in this course. It totals 35%, which is kind of odd for the math department. Sometimes there's some classes where homework is about 10%, but it's in my view that this is the most important way to succeed and really absorb the content. It's all based on how much work you do. So I'm trying to give this a huge weight between these two components. If you're staying caught up on the homework in this class, if you're sending in your quizzes on the regular time before the due dates, then you're going to do really great on this component. And my exams are based on the problems I have assigned here, as well as the quizzes. In fact, like I mentioned, the quizzes are your chance to write out a problem as if you're doing a real exam problem. Oftentimes when I write my quizzes, they're pretty much real exam problems where I just change a few numbers. So again, the quizzes are my attempt to say, what counts as a really great exam problem in the first place? So if you're making it through the homework and quizzes, historically with my data, I see people doing fantastic on this component. And then the final exam is really not as big of a deal because the final exam itself is based on the prior exams right here. It is comprehensive, but if we look at our schedule, The only section that goes beyond exam 3 is section 6.3. So although the exam is comprehensive, it's pretty fair to say it's essentially based off exams 1, 2, and 3, and maybe one additional question from section 6.3. So the order is do really well in the homework by just getting into it and finishing off as soon as possible, asking questions when you need additional help, visiting me during office hours or emailing. You'll do great on the quizzes once you've gotten that practice on the homework. Examinations will feel like a formality, and the final exam is just one more redo on some of those common questions you've seen here. So that's pretty much the whole course. There's a lot of information about the exams, but we'll discuss these more as we get closer and closer to a real exam date. But any questions at all so far, folks?
Yeah, I have a quick question. What is the main difference between like the normal calculus class and the survey of calculus? Like, what are we covering exactly?
Oh, that is a great question. So let me pull up a couple things here to help with that one. I want to go to, let me think about this again. Yeah, let me go to this here. There's a lot of ways to answer that question, and I'll go to past. Let me pull up this one. This is the last time I think that I taught the Calculus 1 class. And let's pull up as well this one. This is the last time for the survey class. And so if we take a look at the survey class, a lot of things that we're doing go along the lines of dealing with derivatives, derivative of function, differentiation formulas, product rule, quotient rule, chain rule. But then we're pretty much done with chapter 3 with just a couple concepts like exponential growth and decay as an application, something more about derivatives of logarithmic functions. So if we go to the other calculus class, this one's 4 credits. That's essentially one major difference. Go to the same type of content, chapter 3. Chapter 3, we're dealing with derivatives of polynomial and exponential functions. That's the same kind of stuff. Product rule, quotient rule, that's the same stuff in our class. Trigonometric functions is not in our class. Here's the very first main difference. You're not required to have knowledge about trigonometry. If you do know a lot about trig, I think that's fantastic. Some of the examples might be a little bit more fun than class reading. But if you've never taken trigonometry or you just don't care to discuss it, everything that relates to trigonometry is not covered in this course because it's not a prerequisite whatsoever. So we lose trigonometric functions. Chain rule we still do. This is a really technical section. In the Calculus 1 class, people don't like this section either. But we're doing a survey class, so we're skipping out some of the more technical sections like this one. We still have logarithmic functions we need to deal with. This is a massive application section. We both do this one, exponential growth and decay, but there's just a lot more applications in Calculus 1. So this is rates of change, natural social sciences. Related rates is infamous for being difficult. It's not as bad as it seems. You just need a lot more time to really cover these as an instructor and as a student. So to me, that comparison we just went through, those are the major differences. We cover the same content. The only difference is that our class just doesn't get into some of the technical things, slightly different prerequisites. But when we finish this course, I think it would be really hard to tell if you interviewed a student that took Calculus 1, a student that took Survey of Calculus, tell which student took what class. You'd have to ask very specific questions to really determine that. But does that help with that question there? Awesome, glad to hear that. And maybe another kind of qualitative response this time is one of the other purposes of the survey of calculus is it has a different type of audience. A lot of students that take this class are in a biology program of some kind, possibly a nursing program, those kinds of things. And for that reason, the applications in this class are usually more targeted to being of the nature of a biological application, something from biology, something from medication, something from pharmacy. We do a little bit of pharmacokinetics if you're a pharmacy student and so on. So it has a different target of what kind of applications we drive towards as well. But aside from that, it's a pretty similar course. We're going to be looking into differentiation and integration, which is all Calculus 1 is about as well. And at this point, I think that was an excellent question. Any other questions at the moment about the course?
Hi, I had one question. So back to the exams, were you saying that the exams that we take this semester will be similar questions or the same questions on the final exam?
Oh, sorry, it'll be not the same, but highly similar questions. So,
Okay.
for example, when I go to write the final exam, I actually pull up my document for exam 1, exam 2, exam 3. I select a representative set of problems, but then I do change the numbers around a little bit. It's going to be the same problem in spirit, but different numbers is a way to think about it.
Great, thank you.
Yeah, absolutely. Any other questions so far? Okay, one other thing that's a little bit weird about me is I researched this right here. The registrar has really weird final exam schedules on the Idaho Falls campus. This seems unfair already because the fully online section gets rolled into this weird final exam schedule. Our final exam is scheduled on a Friday, May 9th at 10 a.m. That's just such a weird time. This may not work for a lot of people in this class. So if this doesn't work for you, I do make outside arrangements to try and make the schedule work a little bit better on finals week. So if you're looking at that date there, try and put it in your calendar and you're realizing there's some big problems, you don't have to drop the course over that. We will get the final exam sorted out one way or another so that it's at a reasonable time if that doesn't work. But I think we're getting towards the end of the syllabus. The last part are just statements written by the university itself. Every one of these statements are highly, highly important. But if you read them once, you probably have the main idea of what it's all about. So some statements here that I would particularly point towards are statements on success. And statements on services. There's actually a lot of resources you have available to you as an ISU student. Let's see, academic complaints or grievances. I would say this is extremely important as well. If there's something going on in your class and you just feel like that doesn't make sense, what kind of school would want to do that, or instructor? You do have avenues of complaint. For example, within the math department, this is your guy, the department chair, Dr. Ralt. If you go to your department chair, maybe it's in a different college and that doesn't get resolved, you can go even higher. We have a provost, dean of students, all sorts of avenues. If your answers you get from your instructor or the department chair just don't seem about right for whatever is going on with the complaint or grievance, keep on escalating, because if you know it just doesn't seem right, you probably are correct. So that's a pretty big statement that you should be aware of. Title IX is extremely important. This is a federal law. There's a lot to say here. And aside from that, I'd say everyone in this class, if you don't read anything on the university resources, at least read the accessibility statement. They're all important. I can't say one is more important than the other, but that's the one statement I'd say it's worth reading. And hey, it's short and sweet, so that helps out as well. But again, that's our run through on the syllabus. It's not a careful reading, but just a quick look through on the key elements. If I have to make any change on the syllabus, maybe I have a typo or just something that's just totally wrong in there, this is the steps I usually take. Any document that has to get changed will have a statement that goes revised in red. And maybe it's something simple like I meant to say AM, for example, who knows? All my changes down in the lower part of the document would also be in red. But let's get out of here. Next thing I want to do about the course is just introduce how the Moodle website is going to work. Majorly because I use this Moodle website for our course very, very extensively. Excuse me. Essentially, everything that happens in this class runs through this Moodle website in one shape or form. So for the quick tour, the announcements forum, I do make quite a good use of for anything that has to deal with, say, I guess announcements, of course. So I'll try to make use of that. The ISU book bundle link, I deleted it once and the ITRC, Moodle's technical support, restored it. I don't think it does anything for us in this class. If you're going to use the homework system, you want to just click right here to register into WebAssign below. Click on this one where you're just going in to work on your homework, or just make a new shortcut on your browser. let's maybe click on this for just a bit, just to show what it looks like. So if I was thinking of myself as a student, I'd probably log into the course page for Survey of Calculus, click on WebAssign. This is assuming we've already registered. Let me click on sign in. And I practiced this once, but I'm gonna hope I remember my password. Oh, it remembered it for me. That's kind of nice. Now, finally on this page right here, well, you wouldn't see this page. Let me click view as a student. You should see something about like this. They try to make these views pretty compatible with what the student actually sees. So this is the student view. Sometimes there's a couple small differences, especially if you have more than one Cengage class. You might have an extra page to click on the right class. So we'll talk about this page a lot more, but the first thing I want to talk about is, where is your textbook? It's this link right up here where it says My eBooks. Your assignments next are just this listing right down here. So currently section 2.2 is on the table. It's not considered officially assigned because we haven't even started that section, but it's available if you want to take a look at it and work ahead. You're always welcome to. If you click on My eBooks, I guess I have to click on it again. It should take you to a whole new web page that looks about like this. At this point, you're inside the actual online textbook. There are no difference from this textbook and the physical copy. So if you decide you need the physical copy, it'd really only be because you've determined you learn better having physical media in front of you, something that you can actually touch and turn pages on. If you feel like you might learn just as well or not too badly on this platform right here, you might be satisfied with the eText. The way the eText works is, well, just about as like you'd expect. Our first section is 2.2, so click on this right here in the chapter 2. We have to load our textbook. I'm in the wrong spot, so click above here, the menu bar. And what is up with my Zoom? This is at 160%, that's crazy. Go to section 2.2, limits of functions at infinity. And now you're reading along the textbook. It's kind of strange because the format is exactly like a real textbook, but the white space down below is a little bit weird. There's lots of little tabs you have to click on and then scroll through. But this is the real deal. This is our textbook. The best way to use this textbook is scroll slowly. So what I mean by that is when you take a look at example 1 and you go to the part where it says solution, scroll back up. You want to read this right here. Try to work the problem all on your own without the assistance of the solution in the textbook. Even if you get stuck, it's always a good idea to try to make a start on it, attempt it on your own. Then compare your answer with what the book did below. And this is a fantastic way to learn mathematics and read mathematics. You always want to have a pen or pencil, paper available next to you and read these kinds of things actively. Then it'll show the big solutions and things like that. Let's keep on going through this first section. The definitions are things I bring into the course notes, sometimes verbatim typed out. So that way, when you're taking notes in this class, you don't necessarily have to have a busy hand writing down as fast as possible. Everything I put in my lecture notes are just things directly out of the textbook. Keep on going. And if you get to the very end of the section, it's actually taking me quite a while, you get to the exercises. But these exercises are pretty much the same exercises as what you see in WebAssign. The only difference with some of these problems is WebAssign might randomize by changing this number to a 5, for example, something like that. If you notice anything is red in your problems, that was a randomized element. So pretty much this is our textbook. You can come here to take a look at problems and get answers to problems that weren't assigned just for additional practice. I think most people are going to be using this textbook mainly just for the reading itself. So let me close that out. What maybe first I should ask. Any questions about the textbook at the moment? Okay, I don't want to spend too much time in WebAssign because, like I mentioned, not everyone's registered, although, hey, that went up by 1. 11 people are registered so far, so that's awesome. When we come back on Thursday's class, we'll take a deeper dive into WebAssign, demonstrate actually working WebAssign, how to get help within the system itself. And so that'll be a more meaningful discussion than doing it right now when not quite everyone's ready. So let's put a pause on here right now. I would say for day one in the class, if you make it your project to get registered for WebAssign, you're now considered fully caught up. If you get that done on Thursday, at the end of Thursday, you're still in great shape for the course. Below, I have a support link. Let's keep on looking through the Moodle website. Below even that, again, that's our Zoom link. And this is a link that you might come back quite often. If you miss a class meeting or something along those lines, click on the record lectures link right here. It'll direct you to a YouTube playlist. This is where all the class recordings end up. It's empty for the moment. We're recording our very first one. It'll end up here. Down below, that's our Desmos calculator. This is just for us to demonstrate fast computations, really quick plots, nothing too major. So think of this as me using a calculator just as a class demonstration tool. Below, I have some optional reading on why study calculus, how to study calculus. So these are good, just extra resources to take a look at for study tips and extra study problems. Let's maybe take a look at a couple of them. The one, why study calculus, is a really long article, but if you want some motivation on the value of calculus, the way it's being used in the physical world, this is a really great write-up. On the tab to the left, well, it's just more stuff that you could take a look at for additional support on mathematics and calculus. So that's the first link right here, a little bit more of a modern one. The one down below has the same sort of resources. In addition, a lot more resources are just about study methods. If you feel like you're studying very well, you've got a great process, you may not be as interested in this link. If you feel like you need to change up your methods, your process for studying on a course, particularly for a math course, this is a pretty good read. And it breaks down into even more general tips down below for interesting articles such as taking notes and so on. I think the reading on taking notes is a pretty good one as well. But our class is slightly unusual because, well, we're presenting this class through a projector using digital notes, and our notes actually look like this. Let me open it up. So this is section 2.2 I'm clicking on here on the right. I've duplicated my files as what you see here on the left. This is just the PDF version of what we're about to open. Oh, hang on, I'm having a issue getting my windows aligned here. Okay, so this is what my lecture notes look like. You'll notice there's tons of white space in these notes. The purpose of that is you want to think of these notes as being essentially a gigantic worksheet targeted to section 2.2. We fill this out as we go and study the section. And that means there's a lot of different ways you can take notes in this class. If you're a more traditional person, you might have a paper and pencil, and you could be jotting down things, but you probably don't want to jot down that entire definition. Again, it's pretty much verbatim right out of the textbook. It's available in the course notes. We discuss these as you go. You want to take notes on what we add here. So if you're traditional, working with paper and pencil, then focus more on what we add in the white space and try not to copy down these during class because that's a lot of writing. It'd be hard to think and write all that all at the same time. There's like a traffic jam in your mind. Other ways to do this is if you work digitally, I see 2 laptops in class and Zoom, I'm assuming that there's about 13 computers running. You might just download the notes and fill them out as we go. I'm using digital tools like this to just draw in my work, but there's lots of things you could do digitally to make this work out. You can print out these notes by accessing the PDF file down here, or go to the blank lecture notes folder where, oops, I'm supposed to put the Word document there as well. That was a omission on my behalf. Let me put in a quick note. All it's to do, we got to do this. I will say here, add Word documents to the blank lecture notes. So if you like Microsoft Word, I think that's a decent way to annotate digitally. You'll have a Word version here. PDF version is just for as extra compatibility, as much extra compatibility as we can give. So again, if you're working digitally, you might find a lot of value on just pre-downloading the notes or even just printing them off if you want a hard copy. Focus on what we do in the white space. Let's see here. Still going through the Moodle website. That takes us down to the current week we're in. So everything up here, think of as the class resources. Things get built over time, like this folder gets built up as we go from section to section. And if you came back on Thursday's class, whether you're coming in through Zoom or coming in person, looking at the projector up there, this is pretty much where we're going to be pointed towards. I'll put a quick note to say what example or problem we're working on in the notes. There'll be an indication of what the reading is. So here, I indicated just read section 2.2. That's my way of saying all the content in that section is going to be used for the notes. So that means they're all fair problems on the exams. But occasionally, there's going to be extra information here that says read these specific pages or omit this subsection, things along those nature. So this part of the website is just me indicating what portion of the textbook you want to read. Down below is the notes. At the moment, these are totally blank. But as we walk through the course and fill out these notes, the document here gets updated for the total solutions relative to that section. So essentially, that's how we're going to work the course on a week-by-week basis, section by section. And think of this Moodle website as just a gigantic resource. We continue to scroll through here. I have other pertinent dates like, say, the last add drop date, the first exam date, a little bit more detail on calculators allowed on exams. Might as well open that while we're looking at it. This is my big recommendation. It's a cheap, fast calculator where you can put a long expression in. And the ones we're excluding are just the graphing calculators like the TI-83. Going down below, we have information all the way down to finals week. But this is a pretty live document in the sense that once we get about to the weekend of this week, I start to fill out a lot more information on this, saying what are the exact sections that are going to be on exam one, what resources we'll need for the practice problems and those kinds of things. So a lot more information gets published here as we get closer and closer to the exam. Well, I think I ran out of things to say. It takes a while to actually say all that kind of stuff. We're about 42 minutes in. Any questions or comments, concerns, or anything like that whatsoever, folks? Okay, one additional thing I should describe that I think I neglected to do is we have, 11 students so far registered with WebAssign. Looks like probably using that link there. I would bet the majority of those students are opted into the ISU Book Bundle program. But if you have opted out of the ISU Book Bundle program, which makes sense with plenty of students, then the way you would register for WebAssign is still using this link right here, but you would have to purchase access directly from WebAssign itself. So you would click on this link once more, click on enter class key. So this is if you have opted out. Go back to ISU 371. Well, this whole thing right here, let's just copy it, paste it in. So that'll be the right thing. We'll click continue. Give it a moment. The internet seems spectacularly slow today. Maybe it's just Cengage. Oh, it says instructor center, but typically what it'll say for the student that opted out is instructions to purchase your access code, and then you would register in just the same exact way. So in other words, if you're in the ISU Book Bundle program, they provide you with an access code. If you're not, if you've opted out of the Book Bundle program, you just purchase it separately. Okay, well, I think those are the main things I want to discuss. Let me turn it back to the class. Any questions or comments or concerns so far? Okay, well, at this point in the course, here's where we got through most of things so far. I think a lot of instructors at ISU would just use the remaining additional time to start running through the content. We go to 3:45, but week one is kind of overwhelming. We're figuring out stuff. I have additional tasks of getting registered with WebAssign, so I don't want to go too far. Let's just do a couple of quick examples to get a feel for how these notes go. I will call it a day a little bit early. So this is the very start, folks, of the entire course, limits of functions at infinity. We have a lot to discuss here. We need to discuss what is a limit, what does it mean to take a limit, and what does it mean to take a limit of a function at infinity? These are all very big statements. That our whole goal in chapter 2 is we're trying to get a feel for what is the derivative in the first place. And you know what? Because that's the major target of this entire course, let's include that right here. Before we hit this definition, let's do a qualitative task to ask and answer the question, what is a derivative? So this is what the course is all about. Even when we go to deal with integration, we are still dealing with derivatives. We go backwards and call them antiderivatives, but it's all the same kind of thing. So if we get a good feel for what a derivative is, we'll know what the course is all about. So here's how it starts. Let y be equal to f of x. What I've defined here is a function f of the independent variable x. The output of the function is just going to be called y. Well, let's plot that function to get a feel for what it looks like. I'm going to emphasize quadrant 1 in my plot, just to make the plot look a little bit nicer. And let's sketch the graph of this function. When I sketch the graph of this function, I just have to make sure the vertical line test is never violated. So in other words, I'm going to delete this one right here. If I draw something like this is no longer a function. I'm going to have to delete it because any vertical line, well, not any, but certain vertical lines intersect this function in more than one spot. This fails the vertical line test, so it's not the graph of a function. If we do something like this passes the vertical line test. Every vertical line intersects the graph at most once. So now we're looking at a real function. And here's what the derivative is all about. Let's put a point down here. And maybe call it A. What we're very, very interested in a calculus course is something called a tangent line. Let's draw it like this. We'll have lots of practice on a tangent line, but my goal is to draw a line, let's go really light, that intersects on this point A in a certain way. I don't want it to intersect, say, let's just put this one off to the side. We don't want it to intersect like this. The problem with this line is, if you zoom in a lot in this location, the line in black and the line in blue won't have anything to do with each other. But if you put just the right line on there, say this line, we call this a tangent line. What makes this a tangent line is, again, if you take a region like this, zoom in, then the graph starts to look a little bit more like this. Imagining that I drew this perfectly, let's just move that down. Something more like that. If we have a true tangent line, the more and more you zoom in, the closer and closer the black line and the blue line become the same. They become overlapping with minimal difference. They intersect perfectly at the one point A, but we want it to be the best local linear approximation of the function in blue. So this still doesn't answer what a derivative is, but we're very interested in forming this tangent line. Because it's a literal line, it has the format y equals mx. Plus b. We say that m equals the slope of the tangent line. And now we're ready to say what the derivative is. The derivative of f at a is We write it f prime at a. So this prime symbol here is just a sideways directional thing about like this. It's a way to say we're dealing with a derivative. It happens at a, the value where the tangent line intersects. And all this is equal to is m, the slope. That's pretty bizarre in a certain sense. When you get into calculus, the major object we care the most about is that, a slope of the tangent line. We call that the derivative of f at a. I think it's harder still to say, why do we care about this slope of the tangent line? What physical meaning does it have? But we can add this to this document by doing something like this. Suppose this axis was time. If that's the case, and this axis going this way represents a distance, then our slope n has a new meaning. M is going to be equal to the velocity of a moving object at time equal to the value in question A. For maybe a more immediate kind of application, imagine you're driving a car. The distance is just your distance from a starting point, time going this way. The slope that you see here, the slope of the tangent line, that's just your speedometer readout, how many miles per hour that you're going. So slopes are rates like miles per hour. They could be, say, dollars per hour, anything along those lines. And that's the kind of objects we're really interested in. If we get good at calculating derivatives, there's a fantastic amount of stuff you can do with them. The big application of this course is optimization. For example, we want to know, when does something become at its highest value? Maybe if it's pharmacy, you could think about a drug infusion. When is the blood concentration of that drug at its peak? Turns out derivatives help us answer that question in a surprising way. All they are just slopes of a tangent line. But I think a lot of people might notice one fundamental problem with all of this. How do you calculate the slope of a tangent line? There's exactly one point here. We've been told all our lives in our algebra class, if you want the slope of a line, you need 2 points. This is a huge problem for us. And this is the whole reason chapter 2 exists. To get the slope of that line, we have to do something called taking the limit. So chapter 2 is all about limits, so we can get better and better at that process. So think of this again. This is a page we'll come back to. If this all seems really foggy and vague, you're not too sure what's going on here, worry not. We're going to come right back to this when we go to define the derivative and move through all these parts in a lot of detail. Think of this again as just an introduction of what we're getting into. So we're interested in limits. And the first kind of limits are going to be limits at infinity, or horizontal asymptotes. Here's our first definition right out of the textbook. It says let f be a function defined on an interval, a to infinity. Then that expression means that the values of f of x can be made arbitrarily close to L by taking x sufficiently large. It's a great definition because it says exactly what we need to say, but if you're like me, it rolled right out of your brain. There's no traction on that. The textbook itself is going to have a big diagram right here, but sometimes that's kind of visually overwhelming itself. Part of our goal is to take a technical definition like this one and break it down with a particular example. And I happen to have one here in my cheat sheet. Here's a fun function to start off. This is the Desmos graphic calculator like we mentioned. We're going to illustrate a definition like this. We need a real function. So we start by typing in f of x equals. I have a function that goes 3x cubed minus 5 divided by the square root of x power 6 plus 1. So here's our function we're going to work on. Let me just make sure this is a good screenshot for us. That should do the job. Okay, now at this point, we could actually illustrate the definition in a better way. First thing we have to talk about is, if you were going to say this out loud, what would you actually say? Most people, when they're dealing with limits, would read this out by saying, the limit as x goes to infinity. So I've discussed that part in the reading. Lim is just shorthand for limit. This x right here is saying what's changing, the variable x. The arrowhead going to the right is just saying x goes to, and, well, we're going to positive infinity of the function f is L. So that's how you would just read out that statement. So if I say limit as x tends towards infinity of f of x equals L, we're thinking about this kind of structure. Now, next thing we've got going on is the function itself, f of x, is this one here, regrettably plotted in red, but let's let the blue and blue here convey that. We're saying here next, we're taking the limit as x goes to infinity. What that means is x goes to the right. And the last big element here is the limit L. What this is saying is f of x. Let's say this may be in a better way. The graph of y equals f of x gets closer and closer to L. So a whole lot of stuff is going on in this thing right here. That's why we're kind of trying to break it down slowly. We have an example function, and there's two kinds of limits we can take. Notice this first part right here. Whatever's indicated here is highly specific. This is one of the big challenges of a calculus class, is breaking down the notation. The notation is technical. It says quite a lot in very little space. So let's practice it right here, right now. Let's take this and write out, excuse me, the limit as x goes towards infinity of f of x equals, and let's compute that limit. First thing we take a look at is the part where it says x goes to infinity. Because of that part, on the portion of the graph we're looking at is this portion, to the far, far right. We're interested in this location, in other words. And the number we're putting here is the height of the graph. Oh, let me say this in a slightly better way. Sorry about this omission. The height of the graph. I omitted this part right here in yellow. I need to say the height of the graph, where we're looking here circled in blue, is getting closer and closer to some certain number. We'll say here on our notes that that number is going to be, excuse me, 3. Because if you're following this point here, your values get closer and closer to positive 3. In fact, we can make it as close to positive 3 as we like by getting x larger and larger and larger. This is something that's very dynamic as well. So if we look at it from the Desmos side, take a value here. As x gets larger and larger, the output, the second coordinate you see there, currently 2.88941, gets closer and closer to 3. The larger you make that value, the closer to 3 it gets. So we convey all this information, the fact that there's a horizontal asymptote, y equals 3. Let's put that in. Simply just means now that the limit as x goes to infinity of f of x is 3 as well. This is a horizontal asymptote, and it's no accident that as you go to infinity, the value of the limit is the value of that horizontal asymptote. We'll take advantage of that property quite a bit. So we did it, folks. That's our very first limit. Again, there's two kinds of limits you can take if you're going to infinity. So if your other limit is this one, where it says x goes to negative infinity, this means x goes to the left. Let me target that arrow a little bit better. So every time you read a limit statement, always follow these arrows here that we see in, is that purple? Plum. Always follow these arrows we see here in the color plum, because this is telling you where to even look in the graph. If it says negative infinity, we're going off in this direction. Let's do another associated limit. We take the limit as x goes to negative infinity of the same function, f of x, which is presented by this graph right here. Anyone see what the limit should turn out to be? Absolutely, good call. So the way to think about this one is go to where it says x, right arrow, negative infinity. This is just saying x is tending towards negative infinity. So on the x-axis, follow the curve just going to the left as far as possible. The values are getting closer and closer to -3. So as you said, this means immediately the limit is -3. So that's our, again, another horizontal asymptote, no coincidence as well. This particular function had two horizontal asymptotes, y equals -3, y equals +3, and this one here turned into a limit only because we're going to negative infinity. This one here turns into a limit of +3 only because we're going towards positive infinity here. In other words, this whole limit expression is because of that part of the graph. And this entire equation here is because of this part of the graph right there. So those are our first two concepts when it comes to limits. They're pretty technical. There's a lot to say here. But in my opinion, this is an important concept of how to even read mathematics. When you see something like this, definitely read through it, but don't be discouraged if it feels like it's completely written in a foreign language or if it's just nonsensical information. If you're reading the book, you have detailed graphs here. Those are challenging as well because really what you want to do when you read a math book is build the graph yourself, stages by stage, and then slowly add in the elements that you need. It's actually hard to come back to this page and look at all of the information as it sits right here. It's easier to see it built out step by step. So that's where the recorded lectures are pretty helpful. But sometimes it's helpful to have these as well. And so these notes get override over here on the Moodle webpage. So at the end of class, typically what I do is I save up this document here, republish the PDF with the updated results, and then put the video that we're currently recording in the right playlist. Well, any questions at the moment, folks, with either limit or anything we've done so far today? Yeah.
Would they always be the opposite of each other? Like the 3 and the -3?
Oh, gotcha. It turns out that just depends with a lot of these. So the question is, are the limits always going to be one or the other, or excuse me, a value and then the opposite value? Turns out that's highly dependent on the function. For example, look what happens if I take out the square root and just go x power 6. Now let me make it more similar to this. Yeah, x power 3 plus 1. Now we have a whole different function, and this time the horizontal asymptotes are the same. As we go to infinity, this one's getting closer and closer to 3 on the right. As we go to negative infinity, we're following this direction. It's also getting closer and closer to 3. It's just coming from the above direction now. So it always just totally depends on the function. Another thing that's kind of interesting here is change these values a little bit, and you've changed the limits a lot. The denominator is of a higher degree, so now the limit is 0 on the right, 0 on the left. Make the numerator of higher degree, we don't have any horizontal asymptotes. Neither one of these limits would exist. We would say does not exist on both of them. So those are some of the additional things we're going to tackle on these notes. We'll do one more graphical type of problem like this one to just kind of connect the definitions. Then our big goal is to use these limit laws. That's a big list, I know, but we're going to break this down and show how to calculate these limits when there is no graph available. We'll do these purely algebraically. But once we finish these, we'll probably often call back the graph to see if our answer is even reasonable based on what we see. But other questions or comments so far? Okay, well, this will be our stopping point for today's class. Like we said, we don't want to go too far on day one. That's kind of not nice, a little bit overwhelming. And the work we did so far is just indicating the direction we're going into. The main homework problems from section 2.2 really start our batch right here. So we'll get a better look at these on Thursday's class. So if before you come to Thursday's class, all you've done is take a look at the course materials, get registered on WebAssign, you're on the right track for the course. Any last questions or comments at all whatsoever, folks, before we call it a day? Okay, well, have a great afternoon, folks. I'll see you all on Thursday's class, but if anything comes up whatsoever, don't hesitate to drop into any of those office hours on the syllabus, or just send me a direct email. I'll be happy to connect with you. Take care, and I'll see you all later. Yep, have a good one.